Hello everyone. Today we would like to present our project called Live Facial Emotion Analyzer. This project was developed as part of our computer programming course. So the purpose of our project is to explore how computer vision can be used to analyze human emotions in real time using just the webcam. Facial emotion recognition has become an important topic in computer vision. It is used in many fields, including psychology, security, human-computer interaction, communication tools, and even marketing research. So our goal was to create a system that can detect facial emotions through webcam. The system captures video frames, identifies the face, analyzes the emotion expression, and then displays and logs the results. We want it to be fully automatic and able to detect emotion reliably with minimal user interaction. Moving on to the libraries used. To build this project, we relied on 5 main libraries. So first is the Facial Emotion Recognition library. This library provides a pre-trained deep learning model that identifies the emotion such as happy, sad, angry, surprise, neutral, disgust, and fear. It also uses MTCNN for more accurate face detection. Next is OpenCV. This handles all camera operations. It captures video frames, processes them in real time, overlay icons, and displays the final output to the user. Then we have Pandas. Pandas is used to store emotion logs in a data frame and export them into a CSV file for later analysis. Then we have Matplotlib. This library generates the summary graph at the end of the session, allowing us to visualize emotional patterns. And finally we have Time. The Time library records timestamps for each detection so we can place emotions in correct order. So next is the overview of how it works. So our system is organized into 4 parts, which are input, processing, output, and the logging and analysis part. So these components work together as a continuous pipeline, allowing real-time emotion detection. First, let us look at the input. The input begins with the webcam. Using OpenCV, the system constantly reads each video frame. Every frame becomes the raw data for the emotional analysis. At the same time, the program loads all the emotion icons from the local directory during the setup. So this ensures that the images are ready to be displayed the moment the emotion is detected. So this stage ensures all the necessary assets and video frames and icons are available at all times. Next is the processing part. So each frame is passed to the FER detector. The detector first checks if there is a face in the frame, and if a face is detected, the model analyzes it using a pre-trained deep learning model. The model then assigns a confidence score to several possible emotions, and the emotion with the highest confidence score becomes the final chosen emotion. And if the system cannot find a face in the frame, it returns no face. We also compare the confidence score to a threshold. So if the confidence is too low, we do not log the detection to avoid inaccurate data. Moving on to the output part. The output part handles how the results are presented. OpenCV displays the emotion label and its confidence score on the video feed using text. Then the program overlays the emotion icon on the frame. Finally, we have the logging and the analysis part. So in this part, the system logs each emotion detection that meets the confidence threshold. The log contains the timestamp, the detected emotion, and the confidence score. When the user exits the program, these logs are exported into a CSV file. This makes it possible to review the data after each session and use it for further analysis. Finally, the program uses Matplotlib to generate a bar chart, and this chart provides a clear and visual summary for the overall emotional responses captured during the session. Next, we will demonstrate the system in action so you can see how it works in real time.
Hello everybody, I am going to demonstrate the demo. So on the top left is the facial expressions that the computer captures based on my facial expression. There's multiple of them, and beside the label is the percentage. It tells how extreme the facial expression is. On the bottom is the icon to help me illustrate what type of emotion it is to make it more clear. Okay, so I will demonstrate you. I will walk through each emotion. I will try my best. Okay, so this is the neutral face, which is not moving your face at all. Next is happy. Pretty easy. You smile. Computer captures your smile. Next is angry. Okay. Next is surprise. Okay. Next one is sad, which is kind of hard to do because I am not a very sad person. There is a little bit more of them, but it's quite hard to pull off. So this is the main one, and when we finish expressing our facial expressions, we press Q and the whole process will analyze my face. Okay, let me go to emotion summary. This is the graph showing which emotion I express the most, which you can see is happy, surprise, neutral. Yep, there is multiple of them, and you can use this graph to calculate or use it to do something else.
So the results of our project. So during our testing, the system successfully detects the emotions such as happiness, surprise, anger, fear, neutral in real time, and the emotions were displayed with clear labels and icons, making the program easy to understand. The locking feature also worked correctly, saving all the detections in the CSV file, and the summary graph also displayed the average confidence score correctly. We also observed some limitations. For example, emotions like sadness and disgust were harder to detect because they share similar facial features with other emotions. The accuracy also decreased when the lighting was poor or when the user face was partially covered, but under proper lighting conditions, the system performed very well. Okay, so next are the requirements for this project. So our project meets and exceeds all the required criteria. So we use multiple libraries including FER, OpenCV, Matplotlib, Pandas, and Time. Our code is also more than 100 lines long, and we use more than 5 functions. We applied Python concepts like loops, if-else, lists, dictionaries, and string. We also implemented an advanced concept that is real-time face detection. The code structure is clean and easy to understand. Thank you for listening to our presentation.